In this workbook, we're going to take a look at a very simple problem, and we're going to create a simulation for it from A to Z. I urge you to follow my steps very closely, and if you've read the PowerPoint on the essentials of how we build a simulation, the elements of a simulation, this is a implementation of that approach. So the first thing we need to do is to understand the technology of our problem. We have a problem at hand here. It's a silly little problem where you are buying old motor scooters and repairing them and selling them for what you hope to be more money than you paid to purchase them. In this problem, we identify the technology of the problem, the way we're going to calculate an important metric. And that metric is going to be the marginal return associated with repairing a bought scooter. And that technology comes in the form of an understanding of the metric we want to calculate and also the uncertainty associated with the problem. The first thing we find in this problem is that we locate an average of 7 scooters monthly for purchase in the USA, and we purchase these. And we believe this to be a Poisson distribution. And 7, of course, is the important parameter associated with the Poisson distribution. That is the average arrival rate for the distribution. In part 2, you see here, is we've determined a distribution for the cost of a salvageable scooter, and it is normally distributed with a mean of $3,900 and a standard deviation of 780. So that's what we're going to pay for a scooter. We'll be sampling that distribution, just as we'll sample the Poisson, to determine the cost of each scooter that we buy in a month. Finally, you want to sell these things, and we are going to settle on the use of the uniform distribution, continuous uniform in particular, with a low value of 2,500 and a high value of 5,500. And of course, a uniform distribution is one where every outcome in the distribution has the same probability of being selected. So what's our goal for this simulation? Our goal is to determine that important metric, the monthly marginal return on the scooters that I sell, and then to see how that varies over time and might change as we proceed from one simulation replication to another. Now let's go to the Calculations tab. In the Calculations tab, you can see that step 1A is the creation of our information for our model. The lambda for the arrival of scooters, the mean and standard deviation for cost of scooters, and then finally the low and the high for the selling price of scooters. And this is associated with the technology of the problem. We have to know this information, and our first step in the process is to organize this into something we'll call a brain. Now, we're going to be using 3 distributions: the Poisson, the normal, and the uniform. And the one that's going to be a bit problematic for us is going to be the Poisson, because we don't know how to generate that yet, except to do it by using the data analysis tool pack in Excel. So let me go to this page here, which is the Poisson random variables. What I've done here is I've generated 10 columns or 10 variables with 100 different values of Poisson arrivals for my distribution. Now, that gives me 1,000 possible values to sample from. And just as I did in the example that you saw before in the use of the Poisson distribution, I use the ran between here and here to generate randomly selected rows and columns, and then I use the index function to pick a random variable from this 1000 variables using this randomly selected row and column. So we'll need these numbers and to incorporate these numbers in our solution, in our calculations, and you can see that there's a number here, 5, that corresponds to the number we achieved in the calculations for the random variable. If I hit F9, you can see that this number is going to change. Let's go back to the calculations. Let me end our first part here, and then let's return to the second part of this video presentation to finish up the problem.